Alright, hey guys, welcome to day 6 on higher order derivatives. Now first, quick little note here, I clearly didn't read my schedule properly. I thought we were doing the chain rule stuff today, so I apologize if some of you guys are like, oh finally we're doing chain rule, or if you're not excited at all. Regardless, my bad. So what we're going to be talking about is we've been taking the derivative, a lot of different kinds of functions. We've been learning a lot of different rules where we don't have to graph it, find the limit, make sure it's continuous, the whole basics, right? We still need to know that when we talk about more abstract questions where we're answering applications, but that'll come in a little bit later. Now that we know the shortcuts, now we're going to be talking about not just when you take the first derivative, which is what we've been doing this entire time, it's when you take a second derivative, a third derivative, a fourth derivative, so on and so forth. So scrolling down here, the only difference in notation is typically you'll see an extra apostrophe for y double prime or y triple prime. In addition, you'll also see that when we talk about the official definition of derivative written out like so, it's just the second derivative of y in terms of x, second or third derivative of y in terms of x, so on and so forth. It's just different ways of writing the same idea. Get used to both of them. Obviously the easier ones are the first two, but get comfortable seeing the second one as well. Okay, so the reason why this is important, and just to help you guys out with physics, if we say that the normal function is a position function, so if the graph looks like this, like a roller coaster, this is the position of the roller coaster over time, right? Something like that. We can then say the first derivative is the velocity of the function over time, and we take the second derivative, it is going to be the acceleration function. How quickly is it accelerating? So we'll get to more problems like that when we get there, but for now, just kind of use that as a application that makes a bit more sense in a concrete manner. So let's go and pick a couple of these here. Number one's fairly straightforward, so I'm going to pick one that might be a bit more tedious here. Let's pick number 3. That's actually a really good one to start off with. So number 3, we're going to start off with the first derivative. We want to find the second derivative. So to find the second, you need to find the first. So to find the first derivative, we're going to take derivative of these two terms here, take it separately. Derivative of x is 1. And now here is where the question comes into play is, do you use the quotient rule, or can you manipulate it so it looks more like maybe a product rule? In this case, you actually can do so. The way we're going to go about it is we're going to just change this so it's 32x to the negative 2. Now this one we don't have to worry too much about chain rule because the 32 is a coefficient. We can just kind of leave it out the front there. And so what's going to happen is we're going to get minus. The 32 is kind of just factored out, so to speak, or just left out. X to the negative 2. Negative 2 comes down, multiplies to the 32, we get negative 64. And then x gets raised to the power, which we increase by 1. And so that becomes negative 1 there. Making sure we're good to go. Should be all set to go. Nope, sorry, messed up. Not increased by 1, it's decreased by 1. Forgot my rules there. I was like, hold on a second. Did I make a mistake in my previous problem sets? Nope, I just didn't do that correctly there. So yeah, it should be decreased by 1. Okay, so that's the first derivative, right? We do the process again for the second derivative. You take the first derivative and you derive it. Derivative 0 or 1 is 0, it's a constant. Same process again. Oh, 64 is the coefficient, or negative 64 is the coefficient. We have a negative 3 exponent. Same process all over. So this time, when we become positive, we bring the negative 3 down. So that's 64 times 3. That's 18 times that. So 196. And then x to the negative 4th power. And there you go. That's your second derivative. Notice how much easier this problem was because I didn't have to use quotient rule. And as a reminder, quotient rule is there for the scenarios where you need to use it. Once you learn chain rule, you'll rarely use it. But it is a good thing to keep in mind just in case something happens where you forgot about product rule, you forgot about some other things that could work out to help you turn a quotient rule into a product rule. Do what you can to make it easier for you, and if quotient rule is easy, go for it, by all means. I just don't like it, because that's a preference problem. Okay, so moving on, let's pick another problem here where we could use, actually, they're all about second derivative. Y is the third derivative, but that's just if you know how to use sine and cosine, that's pretty much straight away there. 6 was similar to what we just did right now. Let's try 8. So we want to find the second derivative. So to find the first one, we're going to do dy of dx. Okay, so it's going to be, in this case, it's going to be product rule because we have a product of these two terms here. So it's going to be derivative of the first one, so that's just 9 times the second function plus the first function itself times the derivative of natural log of x. Hopefully you recall this is 1 over x. So clean this up a bit, we get 9 natural log of x plus, in this case, lucky for us, the x's cancel out. So we do it again. So we do the second derivative of y in terms of x squared. And I guess some of you might ask, why is it x squared? It's probably because we're taking the original x, and because we derived it twice now, we're basically taking it in terms of x squared. Okay, so let's clean that up there. Okay, so same thing. We now have our two terms here. So this first one, it's going to be simply 9 times the derivative of whatever natural log of x is, which is 1 over x. And last but not least, that's going to be 0. So that's just 9 over x. And there we go. Squared away. Okay, that was a lot easier than I expected. So I'm just like, should we just try another one just for the sake of making it easy? I'm trying to think what's a good one for you guys to try. If I could only talk to you guys at this point and like actually get some comments about what to try. 5 is straightforward because, you know, derivative e to the t is always e to the t. It's just what happens elsewhere. But for this one, it is product rule. Yeah, let's try it. Why not? Let's just go for it. So for this one, it's product rule of this times that. So g prime of t is going to be derivative of the first term, which is 5, times the second term, plus first term times derivative of the second term, which is just that. So you're left with 5 et plus 5 t times e to the t. Some of you may think, hey, Mr. Brett, can't we factor out a 5 e to the t? You can. The only problem is at that point, do we have to worry about... Actually, let's do it real quick. Let's just, might as well. 5 e to the t, quantity 1 plus t. Oh, problem with that is, yes, it's product rule because it's this times that, but we do need to worry about chain rule because there's a function inside here. So we're going to skip that until we learn chain rule for day 7. So we're going to skip that for now. G double prime of t, second derivative, is going to be first one, so that's just going to be 5 e to the t plus. And you've already figured out that the derivative of g of t, so the derivative of this whole thing right here, becomes this. So I'm going to cheat a little bit. We know that this, when you derive it, becomes this. So what we're going to do is we're going to do some copying and pasting here. This is like recursion, where you're using the previous term to figure out the next term. And so then we're left with, that's going to be 5 plus 5, that's 10 e to the t plus 5t e to the t. There you go. That's it. Use shortcuts and tricks as you need to, just to help yourself out there. There's going to be a couple more problems in the problem set where you might utilize some tricks here and there. But really, until we get the chain rule, everything else at this point is just, are you comfortable with the rules? Are you comfortable manipulating different terms and factoring things out as you need to, or maybe seeing some patterns and utilizing, like in this problem right here? So give the problem set a go, get used to the vocab and the lingo, and you should be squared away.